Hi guys, this is going to be doing number 7 from the Segel book, and what it reads is something like this. An enzyme with a Km of 2.6 times 10 to the negative third was assayed at an initial substrate concentration of 0.5 molar. The observed velocity was 5.9 times 10 to the negative fifth moles per liter per minute. If the initial substrate concentration was 2 times 10 to the negative fifth, what would be the product concentration after 5 minutes and 10 minutes? Oops, wrong one. Okay. So the first thing that we can carry over from our last problem, which is number 6, which I definitely recommend you guys watching before watching this one, is that zoom out a little bit more. Okay. Is that when S is much greater than Km, right? V equals V max. So what that means is that when we have a substrate concentration of 0.5 in our Km, this is S, equals 0.5 molar, and our Km equals 2.9 to the, sorry about this, 2.6 times 10 to the negative third. You can see that the substrate concentration is much greater than the Km. Therefore, the V equals V max. So our V max is going to equal whatever that velocity was at that time. This is going to be on 5.9 times 10 to the negative fifth. Let me see if this works better. Not really. Okay. So, what does this mean? So this question right now, so now it's asking what happens when the substrate is now equal to two times 10 to the negative fifth. What would the product concentrations be? So 2 times 10 to the negative fifth. Okay, so they're asking for what is the product at any given time. So product at any given time. I'm going to write this out like this. It's going to be V equals S over Km plus S V max. And so what you have to do is you have to realize that V equals dP over dt, which is what we're looking for. However, we don't have product. We don't have an equation for product. So this also equals negative ds over dt. Okay. Also, something else to know, Km down here, which is 2.6 times 10 to the negative third, is much greater than the substrate. So when we have this equation, this S pretty much becomes 0. And so we're left with S down below becoming 0. S up here stays here because it's multiplied, but when it's added to that, it's pretty much 0. So now V is going to equal SV max divided by Km. Okay. So what we're kind of looking at, just to kind of recap what I said in part 2 of number 6, this line, the straight line up here represents V max. This is V substrate. And 1/2 V max is when Km equals our substrate. Okay. So when Km equals substrate, this equals 1/2 V max. That doesn't really matter right now, but what does matter is this was just kind of a fact that you should know. So you're not really ever going to have to deviate how much product is being made in this part of the curve, because this is a really difficult part of the curve to integrate. And so in 6, they had you figure out how much product was being made in this part of the curve. Now we're going to try and figure out how much velocity or how much product is being made during this part of the curve when Km is much greater than our substrate. Okay. So what that means is that we have this equation, and up here V equals dP or negative ds over dt. So I'm just going to drop this all the way down here and say, instead of writing V, I'm going to write negative ds over dt is going to equal V max divided by Km S. Now I'm going to switch this out, so now I'm going to divide this side by S and multiply this side by dt to get ds. I'm also going to bring the negative over here. Divided by S equals negative V max over Km dt. And we're going to integrate both sides. So now we're going to get ln of S minus ln of S0. Okay, this is what you get when you integrate. And the reason I kind of already found out Vmax, I kind of knew ahead of time I would have to, but sometimes you don't always know. So what that means is that when we get down to this point, they give us time points, they give us our Km, and they give us our substrates, but they don't give us Vmax. So now what we're really solving for is, again, we're solving for product. So that isn't in this equation, but we do have another equation, and that is SO, which is substrate I get at the beginning, is going to equal ST plus PT. So substrate I get time given T and product. What that means is that our initial substrate is either going to be still in the substrate or in the product form. It's never going to, this total amount is never going to change. I'm going to bring this all back around. So we can also combine this too. We can say that